All right, so I'm recording now. I totally forgot to start the recording from the beginning. So we're still on the bell work though. As a very quick version of a recap, it's the same thing we did last class. We're evaluating a function when we have a value of x. We just said for the number one, evaluate the function just means solve the equation below. So evaluate the function just means solve the equation below, and then when x equals 2. So to solve the equation below, when x equals 2, we just said, okay, well, all we do is we replace x with 2. So now we would just say 2 plus 4 equals 6. And then we would rewrite it as f of 2 now, because we're going to replace the x with 2 everywhere. So f of 2 equals 6. And then we said that notation just means the answer to the equation, that's kind of what f is, the answer to the equation when x equals 2, which we got from right there. So that kind of matches up with that. We just plugged in 2 in there also for x. So the answer to the equation when x equals 2 is 6, equals 6. So that's the quick recap. Now we're working on the graph. We said when you do a graph, it's the same thing. We're solving, we're evaluating the function. Oh, and this is for everybody. I forgot to tell you guys here. This is a function. How do we know it's a function? The graph I'm talking about now. How do we know that's a function? So vertical line test, right? There's no dots above or below each other. Or if we did a vertical line test, we only hit 1 point at a time. I hit 1 point right there, 1 point, 1 point right there, 1 point right there, 1 point, 1 point. There's no point on that graph where I hit 2 points at the same time. No place on that graph where I hit 2 points at the same time. So we know it's the function. So if we want to evaluate the function for x equals 4, so I'm going to erase some of this stuff, it's getting confusing. So again, question number 1 is done. We're done with this. We've already done that. We're on question number 2. They're totally separate. So if we want to evaluate the graph below for x equals 4, that means we just want to know what is my input. What is my output when my input is 4. That's what this means. What is my output? What is my y value or my answer when x equals 4? Well, here's the steps that I'm going to tell you to do. Right here. Let me get this stuff out of the way a little bit. There. Those are the steps. So if you want to write down in your notebooks, when you are evaluating a function using a graph, I'll say it a few times. Evaluating, you just drop the E here and write ing. When you are evaluating a function using a graph, these are the steps in blue right here. There's a lot of us struggle on this part of the exit ticket, and you will see this again on the exit ticket, guaranteed. A lot of you got it right. A lot of you struggle. More than struggled on the equations, where you just plugged in the value for x. I'll say it one more time, then I'll move on. When you are evaluating a function using a graph, and then you write down these 3 steps in blue. You guys online, well, Kylie, it was just you, I think. You can write down those 3 steps. It'll be recorded, so you can also, if I move on, you can always go back and fill in the gaps or get them from somebody else. I'll give you another minute to do it, though, before I go on. And then we'll follow the steps, and we'll do it. So you may want to jot a quick graph down and put these points on there when I write them in. You actually don't even, the points don't even matter so much because we're going to write the ordered pairs for each of them. So as long as you write the ordered pairs, you'll be fine. Alright, looks like most people are done, so I'm going to move forward. You can keep writing. So the first step, it says, label all of the points. That just means put the x and the y value by each coordinate. So if I come in, this one would be, and I'll get out of the way in a second, -6, comma 7. Can you see the black? Right, so -6, comma 7 is that one. -4, comma 0 is that one. 1, comma 4 is that one. 0, comma 4 is that one. 4, comma -3 is that one. And then 7, comma 1 is that one. So that's your first step. Label every point. Again, this is if you're struggling. I won't grade you based on doing this. If you know the answer without doing all of this, that's fine. So next, find the ordered pair where x equals the number they give you. Well, they gave us a 4. They said x equals 4. That's what it means in step 2. What number did they give you? What value of x did they give you? Who am I going to call after this one? Anthony. Which point is the correct coordinate, the correct ordered pair for that has a value of 4 for x, where x equals 4? What's that? Which one is first when we do a coordinate? X is first, so you just told me 1, 4, so it shouldn't be 1, 4. That'd be the y equals 4. So which one is the x equals 4? Yeah, 4, -3. There will always only be one ordered pair where x is equal to whatever the number is they're giving you. Because remember, it's a function. There can't be multiple x's, there can't be the same x with different y values, or it wouldn't be a function. And that's what we're evaluating is a function. So there will never be an x value that's repeated and has different y values. You don't have to worry about that happening. So there's only going to be one ordered pair you need to pick. And in this case, that's this one. This is where x equals 4. Now we have other ordered pairs, like here x is -6, here x is -4, but that's not what x equals. X equals 4. Here x is 1. Now y was 4, so don't get confused between x and y, because y is 4 in that one, but that's not what we want. Here x is 7, so that's not close. Again, here the y is 4, but we don't want y equals 4. We want x equals 4. So the only one where x equals 4 is right here. So that's your next step, is find the one where the x value matches up. Last step is just, your answer is just whatever the y value is for that ordered pair. So our answer to this is just, well, what's the y value? Amorian, what's the y value for that one? Well, -3. So your answer is just y equals -3. That your output, your y value, that's your answer. So when you're solving, you're evaluating, you're just coming up with the y value. So there's the 3 steps. If you're struggling with that, you now have a full process that you should have written in your notebook for Wednesday. Restroom, phone in there, and then you can grab the pass. Any questions on that before I go? I will expect you, I might even have more than one this time with graphs on it, since that was the one that we had the most trouble with. Because you don't do any math, so it's easy for me to put multiple questions like this on there, because it shouldn't take you any time at all, really. All I guess if you have to write down all the coordinates, it might take you a little longer, but. Oh, the other way you do it without writing the coordinates, you would just circle, well, where is x equal to 4 on my x-axis? Well, it's right there, right? That's where x equals 4. Okay, well, then that means this is the y value I'm looking for. Well, where's the y value? Well, the y value is right there, -3. So that's the way you do it without the coordinates, without writing the ordered pairs. You just find the x value, find the ordered pair or the point that goes with that x value, and the y value is. All right, so moving along. So this next stuff will be on there as well on your exit ticket. This is new material. I say it's new. It's not super new. All right, so here's our objective. We're going back to the whole y equals mxb thing, and we're going to create equations again in this format. Told you you'd see this a lot in this class. I'm not going to zoom out. Can you guys see that okay in the back? Yeah. Yes, little. Let me zoom in. See if I can zoom in one more time. I'm afraid if I zoom in one more time, it's going to be really. I think I have to go all the way up to the largest. Oh no! All right, that'll work. We can do that. All right. So we're back to this y equals mx plus b slope-intercept form. Because it's slope-intercept form, we know two things. We know that value is going to be the slope. And we know this value is the y-intercept. So now the x is not part of the slope. X is not part of the slope. Just the number that is in front of the x, or being really multiplied times the x, is the slope. So that's reviewed. We also know that when it comes to word problems, these are the key words right here that will kind of tell us where the slope is. Per, each, every, and one. They're back there on the wall, so if you want to write them down, you can. They're also just up in the room, though. For you guys, for Kylie, for you, you may want to write them down. So these, I'm talking about these right here, Kylie. Those are the keywords in a word problem that tells us that number would be the slope. So here's the new stuff. It's not really that new. We've talked about it briefly before, but so slope actually here, let me write it a different way. So slope is the same thing. Slope is the same thing as the rate of change. You're going to hear me call it rate of change moving forward mostly, though. There will be some questions on even a state test, even like your test next year, that's your state test for this class. Well, for algebra, not this class, but all of algebra. They may just put an equation up there and put a number in that where that m is, and they may just say, what's the rate of change in this problem? They won't do that for slope normally because they know you're used to seeing it be called the slope, but because it's not always called rate of change, they will make a pretty simple question like that. So if you just know slope is the same thing as rate of change, you'll get some questions that easy on even the state test. And I might do something that easy as well for next ticket, maybe next ticket. So the slope is the same thing as the rate of change. Here's some examples of rate of change. And there's an infinite number of examples, but here are some common ones. "55 miles per hour." Again, we have that word per in there. So that's a key word that tells us. So the rate of change would be this. 55 would be the rate of change, or the slope, if you were graphing a line. It would be a pretty steep slope, so you'd have to draw a pretty special graph to create the line. Another rate of change. Dollars per hour. So like, if you get a job and you have a wage, $10 per hour. That's another slope or rate of change. Common, very common. So the number itself is the rate of change. So that's the rate of change. That's the rate of change. It's the number that is the rate of change. But here's why it's the rate of change. It's because that is per 1 hour. If I said, hey, yeah, we went on a trip and we went 200 miles in 4 hours. Well, 200 is not your rate of change. You would have to say, okay, well, if I went 200 miles in 4 hours, how far did I go every 1 hour? So you'd have to divide that by 4. You get 50. So 50 miles per 1 hour. So that's the key that you need to remember about the rate of change. It's per 1, whatever the unit is, per 1 hour, per 1 day, per 1 week. It's very common that the time or the unit of measure is a time frame. Like I said, hours, weeks, could be even per second if you're dealing with something that falls really fast. Per week, per day, per month. Like if you have a membership fee, a lot of times that's per month. Yep. I'm gonna have to move pretty quickly though, so you may not get all of this down. So you have to catch up on the video or get it from somebody. All right, so these are common rates of changes, and the key for a rate of change is it's per 1, and then whatever the unit is, per 1 week, per 1 month, per 1 hour, whatever it is. And we'll talk about that a lot more. So your next step, I want you to create that table and fill in the blanks. If you think you can. I hope you can. I started you off with pretty easy. So there's 2 rows, 7 columns when you go to create your table. We won't actually get to writing equations today. We'll finish that up on Wednesday, and then we'll do a quick review for the end of the ticket. Today, we'll just do the first part of creating equations. I'll give you another minute. It shouldn't take long to create that table. Doesn't have to be perfect as long as you have all of the numbers on there. Be pretty. If you ever have to create a table in the future, the best way to do it, by the way, is to do the numbers first, then draw the table around the numbers. Because if you try to create 2 rows and 7 columns first, then sometimes it comes out kind of messed up. Although you can always add them onto the end, I guess. So let's see, who do I want to call on? Christian, what's the first number on the top row for the X's? First missing number. Oh, Christian Lowe, sorry. What's the first number on the top row? 1, 2, and then what's the next number? 3. Pretty simple, right? The key is, all you're making sure of is that you have a pattern. When you fill in these tables, which you will probably get some questions like that, not always, sometimes you'll just get the table. You just want to make sure there's a consistent pattern in the numbers if you're filling something in. Now, you may not always have them, they may not always be going up by 1s, like you might get this. you might get this right here. So the x's are clearly not going up by 1. But you have to make sure that your pattern matches up. So, for example, this was a 3. I think that might work. If I did that correctly. So then you could say, okay, well, what would 2 and 3 have to be? And then what would my y values have to be? We're going to get that into a second. But clearly, this is, my point here is this is not as easy to figure out as this. So we're going to get to something like that. The key is, though, you have to, in your mind, you have to think that your final table should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have to create a table like that with all the values in it. You don't actually have to, but that's kind of the first step. Once you're comfortable with it, you'll be able to skip and just go straight to completing the numbers on the bottom. Don't worry about that, though. I'm just saying you're going to get tougher tables. So don't think this is as hard as it gets. So clearly, all we need to do, plug in those two numbers. We're just going up by 1 every time, and those numbers fit the pattern. So every time we go to the next x value, we're going up by 1 every time. That's the pattern in the x's. Ultimately, that's always the pattern we want. We always want our table to be set up so that we're going up by 1 every time we change x values. That's the preferred way we want every table. Now, sometimes we may not have to do that. So what's our missing value on the bottom, Joe? It's not 6, it'd be 5. Because again, we just look for the pattern. It needs to be the same number every time. If the negatives confuse you, ignore the negative. Because remember, it's got to be the same thing every single time, so just find 2 easy numbers. What's the pattern from here to here? Well, I went up by 2. So that means I go up by 2 here. So 5. So now you'd go back and just make sure it's the same pattern. Every time you go up, are you going up by 2? Well, yeah, you are. You went up by 2 every single time. Now this table is already set up the way we want. We're going up by 1 every time on our x values, and we're going up by whatever the pattern is on the y values. In this case, it's 2. So there's your definition. We already talked about it. You may have written it down, you may not have. If you haven't, you need to write it down. So the rate of change, which again, same thing as a slope, it's the amount that the output changes. So we've said many times, output is your y value. Output is your y value. So it's the amount that the output changes, the pattern basically, every time our input changes by 1, increases by 1. So we've already got it set up to where it's increasing by 1. So if it's already set up to where it's increasing by 1, then this is our rate of change, 2. Plus 2 is the rate of change. Now, if we would have been increasing by 2, like let's say the x values were 2, 4, 6, 8, 10, 12, then we couldn't have just figured out the y values. I'm sorry, the rate of change from that. There's something else we have to do, which is what we're going to do next. But if it's already set up to where it's increasing 1 unit every time, the x value is increasing by 1 every time, then we can just take whatever the pattern is in the y values and that's the rate of change. Looks like either some people didn't write it down or they were done pretty quickly. Hopefully they were done quickly. All right. So now let's go and let's, okay, I'm going to zoom out again. So we've talked about equations, and again, y equals mx plus b was on the page before. We've talked about how if we have a bunch of ordered pairs, we can graph those. We can graph a line from the equation, but we can also graph it from the ordered pairs. I don't know if this is going to work real well, but we'll try it. And it doesn't want to put them where I want to put them. Yeah, sure doesn't. Ah, that's fine. We're going to just do a few of them. So I'm going to do just a few of these. Ah, oh, there we go, perfect. All right, so I do know. So 3 and 1. So you'll see now, I only put a couple of them on there, or a few of them. I didn't put all of them on there. You can see that those are lining up. All of those points that I used from the table are lining up and creating a pattern, and that pattern is a straight line. So again, just showing you this is a linear function, a linear equation. It creates a line. Linear is in that word. You see the word linear, you're going to create a straight line based on the slope or the rate of change. So we set up here the rate of change was 2. How do we tell from a graph what the rate of change is or the slope is from a graph? You might remember how we did that. Heads up, Joe. Fernando. I was just going to say, Fernando, are you awake? I think he's. Oh, you know. No, he was out. I was going to say it earlier, but I figured he was out. How do we find out the slope, which is also the rate of change from a graph? Let's go all the way in. Whoa. How do I find out the rate of change or the slope from that? Same thing, slope, rate of change, same thing. You will get some questions where you are given a graph and they want you to find the rate of change straight from the graph. Same thing we did for the slope. We want to know what's the rise and the run, remember? This is where we did the rise and the run thing. So we take any points where we're going right through the corners of squares, which I've kind of already marked a bunch of them, and we say, so for example, right here, how far over, oh, not too far, how far right, which is the run, and then how far up. So that's a very quick refresher, but that's how we do the slope from a graph. This is going to come back again, so if you don't remember that, you need to take that note down again. So my run number was 4, my rise number was 8. If I divide that out, I get 2. That would be the slope. Again, slope is also rate of change. And if you'll notice, that matches up with what we got up here. We got +2. There. We got +2 up here when we did rate of change. And we got the same thing from the graph. And you better get the same thing. Like, you should never get a different slope and rate of change if it's the same set of data, just because you use a graph versus a table. And we could even look at the graph and we could say, well, every time we increase x by 1. So for example, right here, I go from, so x is 0 right here, and then I go to 1 right there. So I'm increasing x by 1 from here to here. Well, what's the change, the vertical change? What's my run and my rise numbers? Well, my run was 1, because I just said every time I increase by 1. What do I increase my output by, my rise? Well, I increase it by 2. So again, that's where that 2 comes from. Every time I change my input by 1, how much did my output change? And that's your output. and x is input. All right, so that's a little, I wanted to do a little review on how to do slope, and again, slope and rate of change being the same thing. You will see that a lot coming up. So now I want you to complete the missing values there. Actually, let's make it part of that. So do another table. I think it's 7 columns again. Yeah. So easy. I'm not even making you do this. This one's too easy. I made this one too easy. Yeah. I meant to delete some numbers down here.
1, 2, 3, 4, 5.
Yeah, I know. I meant to delete numbers down there when I created it. I forgot to go back and delete some of them. So anyway, you fill those in. What's the pattern in the x's? What are we going up by? X's are just going up by 1, right? Which is what we want. Like if we have the x's going up by 1 every time, we are set. We can figure out everything we need to know from that table without doing a whole heck of a lot. All we have to know is, okay, well, if we're going up by 1 already on the x values, what's the pattern in the y's? It's 2.5, right? When we go from, like ghosts in the machine. Oh, I can't stop it.
It's going. Oh my God. Oh my God.
There we go. So the pattern is 2.5, right? If you can't figure out 7 or 4.5 to 7, it's a little easier to figure out 7 to 9.5. You're going up 2.5. So the pattern is 2.5. That means 2.5 is our rate of change, because we already have an increase in x's of 1 every time, which is what we want. That means this number is automatically the rate of change. So here's another way to do rate of change. So if you're struggling with the concept, and I hate just going immediately to shortcuts, I'm sure a lot of teachers do it. This is the way you do it. You're going to take the second y value. Now here's the only key to this. You have to have both the x and the y values. So like, let's say if I had just this, again, and let's say I didn't do any of this stuff. Hadn't done any of this stuff yet. We're just going to use this process. And we're going to say, okay, I need 2 columns where I have an x and a y. So I need those 2 columns. So all you need is 2. 2 columns where I have the x values and the y values. And they don't have to be next to each other. You just have to have both of them. So write that down, actually. I'll probably hand something out on this maybe at some point. You have to have 2 columns. So go back to your table that you used before. I mean, you should have, if you didn't draw this one out, you can use one of the old tables, it'll still work. The key is you need 2 columns where you have the x and the y values. So the only 2 I have are these 2. They happen to be next to each other, but they don't have to be next to each other. You just need 2 columns with the x and the y. You take the second column and you take the y value from the second column. And then you subtract the y value from the first column. So in this case, it's 14.5 subtract 12. The second column is the second one on the right, like we count left to right. So 1, 2. That gives me 2.5. Now, I take the second x value. Again, second x value will be the one on the farthest right. I say 5, and then I subtract the first x value, 4. That gives me 1. And then my last step, my third step, I just divide the y values, it's the change in y values divided by the change in x values. So I just take those two and divide them out. And if you'll notice, we got 2.5, which is the same thing we got when we just did it visually earlier. So my rate of change, as we already knew, this process will work no matter what your table looks like. If your table is not set up where it's going up by 1 each time in the x values, this will work every time. As long as you have two columns where you have an x and a y value. Otherwise, you can't figure out the rate of change anyway. Well, shouldn't say you can't figure it out. Got it? Got a phone in there, and you can grab the path out of there. Phone is? All right. All right, so now I want you to try it again. Complete. Now, if you'll notice, this table does not go up by 1. So we can't just figure out this pattern. So for example, here we go up by 3, right? We go up by 3.03. That is not the rate of change because we're not going up by 1 every time. We went up by 2 instead of 1 when we went from 4 to 6. So 3 is not the rate of change. It's only the rate of change when you're going up by 1. Now, if these numbers would have been 4 to 5, we would be going up by 1, and we could say that it was the rate of change, but it's not. We went up by 2. So use that same process. I mean, you could create the whole table and make sure you're going up by 1s, but there's the process right there. You just want to do that again. Take the second y value and subtract the first y value. Again, you got to pick the two columns where you have an x and a y. So we have an x and y in both of those. Take the second y value, subtract the first, and I'm going to walk around on this one. So second y value, subtract the first y value. Then in the second step, it's the second x value, subtract the first x value. And then the third step, you divide the y number, divide that by the x number. I'll walk around and see how you do. I'll give you a couple minutes on it. I'm going to start walking around before this is up, but that's to tell me to go forward. Looks like some people are done already, so I'll start walking around in about 15 seconds. And we'll move on when it goes on. Should be able to get there. This is a small class. My 7th period, my 6th period. People don't like coming to their last class of the day. Not this one. All right. Done? What's your two columns that you're using? What's your second y value? What do you do? Oh, so it's 8.9. There you go. Then you do the same thing with the x's and you divide it out. Ooh, boy, that's a lot of missing notes there. What? Boy, should have probably said do this before you count the table. Should have had those steps done. So that's good there. Now step 2, you'd be using just the x value. It says, oh shoot, I didn't change it. So I made a mistake. I fixed it up top, but apparently I forgot to fix it. So this is the x values here. So if that was confusing you, that's my fault. I changed it up top, but I forgot to change it in this one. So you take the second x value and then subtract the first x value. I fixed that. Oh, that was the only place I didn't fix it. Yeah. So there, hopefully that clarifies it if that was confusing. That was what was confusing you. Anybody done? I want you to try it though. Try using the numbers. That's going to be that, and then divided by what? What's the second x? The same thing you just did for the y. Yeah. For the x value. So what's the second x value? We'd say that's the first. Remember, we did the second, first. Count left, right. 1, 2, 6. And then you divide those two out. All right, so we're not exactly sure what to do. Well, let's see if anybody. Now you'd use the two columns I circled, because that's the only two columns where we have an x and a y value. You've got to have both values. See if you can do it. I don't want to move on until I see if anybody's getting it. There, that's your final answer. Just that, and then you can put in a decimal. Good. So that's your first step. Then you'll do the same thing with the x values, which are just right above, same word. All right, so some people are, yeah. No, I think you went wrong. Well, with this, subtract that. All right, so some people are getting it. Take a second. I think I just went too fast, and I forgot a lot of you were still copying step down and copying the table. So for the values, I think that's pretty good. Good. If you were able to figure out the values another way, that's fine also. Like if you were able to figure out the values by just kind of figuring out the way the table worked, that'll work. You do still need to understand what the rate of change is in that, because the questions are going to be revolving around what is the rate of change. So I'm going to go ahead and kind of help fill in the blanks. So the first step, I take the second y value. Again, I have to focus on the columns where I have an x and a y. They don't have to be next to each other. I should have done one where they weren't next to each other. But so in this case, these are my two columns where I have x and y. I take the second y value and second x. The columns, by the way, this is the first. So that's always going to be, the one on the left is always going to be the first. The one on the right is always going to be the second. Always. Even if you got negative numbers and they're going down or anything, this is always the second, always the first. Because we count left to right. So the second y value, well, that's this. Subtract the first y value. Well, that's that. That gives me 3. All right, well, now let's do the same exact thing, just we're going to use the x values. The second x value is that. Subtract the first x value, which is that, gives me 2, and then I just divide them out. Or if I make it a decimal, so my rate of change then, 1.5. Make sure you copy that one down because you're about to do some on your own. They're already going to be filled out for you, so you won't have to fill the tables out. And actually, in all honesty, you won't have to do, I'm not going to tell you that. All right, and you'll see, I'm going to zoom out for this just real quick. So we came up with a rate of change of 1.5, right? Well, you'll see if Oh, I don't know if that's gonna work. Yeah, that'll work. If I would have created a table, and if I would have filled in every single gap, like I'm gonna just do 1 through 11. I'm gonna recreate a table because I know ultimately I would love for all the x values to just be going up 1 at a time. That's our ideal scenario. And here they are. I just created it. So now every x value is going up by 1. If I figured this out so that I said, okay, well, what numbers have to go in there in order for the y values to work out? I could say, well, let me just see if going up by 1 works. So if I go up by 1, -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 would have been 2. Well, that doesn't work. So going up by 1 doesn't work. All right, let's try something else. Let's go up by 2. Well, -1 plus 2 is +1. +1 plus 2 is 3. +3 plus 2 would be 5. Well, that doesn't work. That's going up too fast. And then you can try 1.5, and 1.5 will work. So if I go up by 1.5, that would be 0.5. Again, 1.5 plus that would be 2. And now that plus 1.5 would be 3.5. So then I fall on all of the correct numbers. So that would be 8. 1.5 goes up to 9.5. 12.5. So you could try to fill in the table like that if that makes more sense to you. I would just really get comfortable with that formula when you do these example problems. Some of the example problems are already set up though, where x is just going up by 1 every time. So then that just makes, so that makes this down here, the pattern is 1.5, right? The y values went up by 1.5 every time, which again is the rate of change. If these are going up by 1, then whatever the pattern is down here is your rate of change, just like we figured out from the formula. I don't care which way you do it. Hold on just a second. That was a question. This, by the way, is the way the formula will look when you see it in like actual formula form. Question? When he gets back. So write down this formula because ultimately this is the formula. Like all of this stuff just means this, or this means all that. You're going to see that as a formula for slope a lot as we move forward. So that's the formula for slope or rate of change. I'm going to write rate of change, and then under it, slope. We did rise over run, like that's how we did the slope the whole time. They actually wanted us to use this some of the time, but rise over run always works. If you don't have a graph, you could just go straight to this formula. Like if I gave you 2 points and I said, what's the slope between the 2 points? You could just go straight to that formula. We said we could just go ahead and graph it and then we could do rise over run. It's the same thing. The rise is this number. The difference between the 2 y values is the rise. The run is just the difference between the 2 x values because that's the left and right value. So it's the same exact thing. One I just think is a little more intuitive than just throwing a formula at you, because they won't give you that formula on your algebra test. You have to memorize that formula. All right, so here I want you to do these two. There, so there's, you do not have to write the function. So you're just going to find the rate of change for these. And then up top, do the same thing, just find the rate of change. Once you're done with that, there are worksheets up here that you can come get and then start on. That's your assignment for today. These are just practice so that you feel comfortable doing it. So you're not doing any equations yet. You're just finding the rate of change, even on the worksheet. I think there's one or two that says find or write the equation on the worksheet. It's maybe 7, 8, and 9. You do not have to write the full equation yet. Just find the rate of change. I'll zoom in real quick since this is visible. There. So find the rate of change on those. Once you're comfortable with that, if you need help on this, I'll walk around right now and help on this first. Then you can come grab this, and there's other stuff on there besides just this rate of change. As long as you have an X and a Y value. So if you've already got all the numbers, then yeah, you can just pick any two columns you want, and it'll always be the same number. Like if I pick this column and this one way over here, it would come out like, let's pick this one. So 3 and 2, right? So my difference between my Y values is 12.5, subtract 2, so it would be 10.5. Well, if I then say, well, 10.5 divided by, it would be 10, subtract 3, it would be 7. So 10.5 divided by 7 would come out to be 1. So it doesn't matter which columns you use, as long as you have the X and the Y. So in this case, they didn't make you fill anything. You got all the data. You pick any two columns. Just make sure you start with the column on the right and then subtract with the values on the two columns on the left. Same thing we just did. No difference. The only difference is they've already filled all the tables in for you. You don't have to fill anything in. So you can pick any two columns you want on any of these tables. Just make sure you start with the column on the right and use those values and subtract the values from the column on the left. So I could pick these two if I want. They don't have to be next to each other. I could pick those two if I wanted. And say 62 subtract 17 divided by 4 subtract 1. Or I could pick the two that are right next to each other. Doesn't matter. And the pattern on these is already set up to where we're going up by 1 every time, if you'll notice. X's are going up by 1 every time, which makes it really, really easy. So once you're done with those, if you want to come grab the worksheet, there is other stuff. You have to graph. You have to evaluate using just what we did for the bell work. So you have to evaluate, like when they give you X equals this particular number, they give you an equation and they give you the whole terminology of f of X and all that. Again, all you're doing is just solving when X equals whatever number they give you. So in the worksheet, and I'll get to this in a second, once everybody's. So then you're going to draw a graph. So you need to draw a graph, and that's just going to be based on doing the y-intercept and the rise and the run thing. You should all be able to do that. If you don't remember how to do it, do your best. You start with the y-intercept, then you do rise over run once you know what your slope is. Then 7, 8, and 9 are the ones where all you're going to do is find the rate of change. Once you get the worksheet, I'll start walking around more. If you have questions, though, on any of this, let me know. It's a little bit of review. All of this stuff, though, could be on your exit ticket. Basically, your exit ticket is based on this worksheet. So make sure you put some effort into it. Even if you don't know how to do it, try to figure out how to do it. And that way you'll know when we come in Wednesday what your questions are, because that's when your exit ticket is on Wednesday. So if you're trying to go into the exit ticket without having done anything, it's going to make it a lot harder on you. that doesn't work, Joe, that one actually works better, the manual one. That one tends to eat pencils. The manual one's actually a little bit better. Although it does involve manual labor, which I know you guys hate.
What?
If you haven't gotten the worksheet yet, go ahead and come up and get the worksheet. That way I can kind of walk around and help if you've got the worksheet in front of you. Because some of the stuff, like I said, is old review stuff. You need to know how to do that too. You should all be able to do the first three. That was what we did for the bell work. You're just solving an equation by plugging in the value for the x. I can't hear you through the math. Do you want to do what? Need help? Let me know. The second group of problems, you're just graphing a line. You have one of them you have to do the distributive property first. If you don't remember the distributive property, I'm going to zoom out now, by the way. So the distributive property just says, like, if we have a 2 out here, and then you have 6x plus 4, you take the 2 times the 6x and the 2 times the 4, and that would give you 12x plus 8. So I think it's on number 5. Anybody looking at it? Is that the one where you do the distributive property?
Yeah.
All right, so on number 5, you have to do the distributive property first to get a new equation. Then you should be able to graph the line from that equation. You've got to get rid of the parentheses first. You can't graph it based on what they have there. And that is not the same problem. I just made that up. But you should be able to graph. Remember, the y-intercept is the number that's all by itself. That's, you put a point on the y-axis, and then you go rise and run from there. Well, no, there's no your grapher creating a line. You're not solving anything here. You're just creating a line. So you pick the y-intercept, and then you make that the rise and run. Remember? Up. What do we have to do? You got to find out where it's. There you go. Perfect. If you need to put a number into a calculator as a negative number, we said that you type the number in first. So let's say you need to put -2 in. So if you need to put -2 into a calculator, type in 2. Oh, I made my arrow backwards. Type in 2, and then you hit this button. Do not use the subtraction button. That will mess everything up. Sometimes you get lucky with it, but normally it messes it up. You use that button right there. Those are graphing the lines. So that'd be where you started. If you have your notes, if you have that worksheet, or not worksheet, but
Can I go to the bathroom?
Are you going to the bathroom, Ryan?
Yeah.
Did you request that earlier?
Yeah, she did.
There was a sheet that I gave you a while back. Remember, it was like, originally it was 2 pages, and oh yeah, it said steps to graphing. It was 2 pages. It was 2 pages, right? We did this, created it, 2 pages. If you have a folder with all your stuff, the first page is how you do this. Well, not this, how you do 4, 5, and 6. So if you have this, that tells you exactly what you need to know. If you don't remember, I'm going to go over one in a second. But I would hang on to that sheet. That's what we just did. Yep. Now, oh, you'll notice On 7, 8, and 9, they have their graphs vertically.
Okay, isn't he doing one up there?
So, well, we already did them, but,
Okay.
well, no, they're supposed to be doing, they were supposed to do these. We did a bunch before this.
Okay.
If you have a vertical graph, instead of saying find the, well, it's still the second in the first column. The second column is below the first column. So for example, if this is the graph vertically, if this is the graph, ooh, board's tripping out. If that's the graph vertically, our second y value would be the bottom y value. And then that would be the first one. Or if you really want to, you can just do this. Change it into the other kind of graph if you're just comfortable with that. Change into that, and then you just write your numbers going down left to right. If you're more comfortable with that, you can just rewrite it like that. Once you've done it a few times, you'll just kind of know which direction you need to go. That's why we're just practicing as much as possible today, and we'll do a lot more practice on Wednesday before the exit ticket.